Hey guys, welcome back to AIT 1003. We're going to jump right into the next segment of this lecture. Okay. First of all, let's talk about area, and we're going to briefly just touch on that. Again, area is pi r squared. Okay, pi being 3.1416. If you want to, you can just use 3.14. That gets you close enough. The 16, if it's a little bit shorter to drop that, that's fine. Okay, it won't make that much difference in your calculation. But the pi is 3.14. The radius, which is half the diameter, we square that, which means we multiply it by itself, whatever the radius is. Okay, and then that's how we multiply those two together, and then that's how we get the area of our cylinder. Now, the cylinder has a couple of different parts to it, and a couple of different sides. But on this side, this is what we call the cap end. Okay, and this is the area in which we port fluid back here. And the pressure builds up, and it forces the cylinder this way, okay? Forces the piston this way, and the rod extends, okay? And the oil that's on this side is ported back to the tank, okay? If we want to do the exact opposite, we port the pressure to this side, fill up this chamber, and it starts to push the piston this way and retract the cylinder. This oil that's trapped in this chamber is ported back to tank, okay? So that's how it strokes back and forth. But the two sides of the piston is different. There are two sides, and they are different in that on the cap end there is no rod, and on the rod end it's less surface area. And we're going to talk about that shortly. But first of all, let's talk about the cap end. Okay, that's on the extend side of the cylinder. Okay, and we differentiate the extend side from the rod side when we write this by saying the extend side is A. Or the area, when we're talking about the area sub EXT. The area of the extend side is known as A sub EXT. That's how you differentiate from the return side. We'll talk about that shortly. But in this example, we've got a 4-inch diameter piston, okay? So to find that area, all we have to do is take the radius of that 4-inch diameter, and the radius is half the diameter. So half of 4 is 2. We square that, which is multiplying it by itself, 2 times 2 in this case. We wind up with a diameter of 4, okay, or the number 4. And so the area for our extend side is 3.14 times 4, and we wind up with an area on the extend side of 12.56 square inches. Okay, so if I were to apply 100 pounds of fluid pressure per square inch PSI to the extend side, I could have a force of 1,256 pounds. We could move something 1,256 pounds theoretically by applying 100 pounds of pressure from our pump. Okay. Now, using our formula, remember we said that if we've got 2 of the elements, we can find the last or the third one. Okay. Well, in this particular case, we know that our area is 12.56. And if we apply a pressure of 250 pounds per square inch, I'm just making this up, but if we dial our pump up to where the output pressure would be 250 pounds, okay, then we can move a force of 3,140 pounds, okay? So, we knew 2 of them, and we got the third one. Now let's switch them around just a little bit, and if we know, we're going to still use the numbers so you'll know what they are, but if we know our force of 3,140, and we know that we have an area of 12.56 square inches on that extend side of that piston, then what pressure are we going to need to be able to move that 3,140 pounds with that size of cylinder? Well, we just divide the force by the area, and we wind up with a working pressure needed of 250 pounds per square inch, just like I showed you earlier. Okay. Now let's change. One more way to calculate this is, if we know our force to be moved and we know our pump pressure can put out 250 pounds of pressure, then how big should our cylinder be? And this is where it gets a little bit dicey, okay? But just bear with me and I'm going to get you through it, okay? We want to try to move 3,140 pounds, and we have 250 pounds of pressure available from our pump. We simply divide the 2, and we wind up with the area of 12.56. So why is that a little bit dicey? Well, this is where it gets a little more complicated. You can't ask for a cylinder, you can't order a cylinder or specify a cylinder based on the square inches of the retract or extend side of the piston. You can't order it with 12.56. You have to give them a diameter, okay? So cylinders come with, specified in the diameter of the cylinder itself, which is the piston size as well. So it's a 4 inch, it's a 6 inch, it's an 8.5 inch, whatever the case may be. It's going off the diameter instead of the square inches. So we've got to get the diameters where I'm going with all of this, okay? Because 12.56 is not going to do it for us. So in order to do that, okay, again, the extend side area of the piston is 12.56. We divide that by our pi, which is 3.14, okay? And that will give us the piston radius squared, okay? Can't stop there though, all right? So we divide 12.56 by 3.14, and we wind up with a piston radius that has been squared equal to 4, all right? Now, we have to take that radius square and we have to find the square root of that radius. So the square root of 4, and I showed you how to do that on your calculator, the square root of 4 is going to be 2. That is our radius, okay? Now, what did we say the diameter was? The radius times 2. Not radius squared, but radius times 2 is our diameter. So we have a radius of 2. We multiply that by 2, and we wind up with a diameter of 4. So, we have a 4-inch piston, and we put 250 pounds of pressure on it. We should be able to move our force of 3,140 pounds. Okay, now that's a lot to take in, but let's try a different set of numbers just to kind of walk through it again. Okay, this time we're going to move a 3,600 pound force, and we've got a working pressure of 400 pounds. What size piston or cylinder do we need? What's the diameter of that cylinder do we need? Okay. Simply divide force by pressure, and we're going to wind up needing a 9 square inch surface area on our extend side to achieve that amount of work, okay, or that kind of force. Okay, but as I said before, we can't specify a cylinder with 9 square inches. We have to go and find the diameter. Okay, we're going to step through that again. So we got an area on our extend side of 9 square inches. Okay, we divide by pi. And that leaves us with a squared radius, the r squared. Okay, it's not quite far enough yet. We've got to take it down and find the radius so we can multiply it by 2 to find the diameter. So to find the radius of a squared radius, in this particular case, we divided 9 by pi, and we wound up with a 2.86 piston radius squared. Okay, so we find the square root. Use your calculator button. 2.86, hit that calculator button with the square root, and then you wind up with a 1.7 inch radius of that piston. So now we got the radius. So what do we do to find the diameter? We multiply it by 2. So we have 1.7 times 2 is 3.4. So we need a 3.4 inch diameter piston. It's not going to have a 3.4. We're going to bump it up because it usually comes in half-inch increments. 3 inch, 3.5 inch, 4 inch, 4.5 inch, and so on. Okay, so we're going to bump this up. We're going to need a 3.5 inch diameter cylinder if we're going to apply 250 pounds of pressure, and that will achieve the 400 pounds of pressure, on this example, and that will give us the 3,600 pounds of force. We can move that force, that weight with that amount of that pressure and that size of cylinder. So, a lot to take in, okay? But we got to keep moving. So if you need to stop the video right here, go ahead and do so. But we're going to keep rolling because now we got to look at the retract side, okay? Now, again, we know the area. We've got that down, pi r squared, okay? Now, the retract side has a rod that has to be accounted for because when we put fluid pressure on it, okay, that rod is extending. Let me show you this way. The rod is extending out like this, okay? All right? So inside that piston, that cylinder, we're going to be exerting force all around on this area right here. But this right here, this is an area that's not getting the pressure to retract. So this is the rod. So we have to take that out of our surface area. And so the retract side and the extend side are not going to have the same surface area. The retract side is going to have less because we've got a rod taking up some of our pushing surface, okay? Remember I talked about the little squares that we could fit in there. Well, now there are going to be fewer squares for that 400 or 250 pounds of pressure to be pushing on, okay? There's fewer squares because this rod is taking up some of that. what could have been our working space, but we've got to have a rod right there. So the surface area between the extend side and the retract side is different, with the retract side having less surface area to work with. So let's go ahead and put this into play. Again, on the retract side, we write that as area sub RET, retract, as opposed to EXT, extend. So we've got retract, extend. That's how we differentiate it when we were writing our equations, okay? So we got the A sub RET that we've got to figure out, okay? And the way we do that, we just subtract the area of the rod from the surface area of the piston. Fortunately, we figured the extend side first, so we already know what that is, okay? So this time, first things first, we've got to figure out the diameter of our rod, okay? So it's the same as figuring out the surface area of your piston face, okay? So you got a rod diameter of 2 inches. Well, we know that the diameter, what we've got to do is we've got to get down to what the radius is, okay? And the radius is half the diameter. So if we have a rod diameter of 2 inches, then that means we have got a radius of 1 inch, okay? So let's put our area formula into play. So we have pi 3.14 or 1416 if you want to, doesn't matter. Not going to make that much difference, but we have pi times our radius, which is half of 2, which is 1, squared. 1 times 1 is 1. So 3.14 times 1, we're going to have a rod diameter of 3.14 or 1416, okay? So now we've just got to subtract that from the area of the piston. Okay, the piston on this side is going to be the same minus the rod, so we already know what we've got over here as far as the extend side. We had 12.56 square inches, which if we didn't have a rod, it would be the same on this side too. But we've got a rod, so we've got 12.56. We've got a rod square surface area of 3.14. So we subtract that, and that gives us basically a pushing surface of 9.42 square inches. Notice what I told you earlier, we got two different areas on each side of the piston. We have 12.56 on this side, and we only have 9.42 because this rod is eating up some of that surface, that pushing area for this piston, okay? So we write this as A sub RET is 9.42 square inches of basically pushing surface area on this side of the piston, because we took into account the amount of surface area that the rod was taking away from it, okay? So we know that the 12.56 and the 9.42, that's our extend and our retract, okay? So now let's put this into play. Let's see how this is going to affect the operation of our cylinder and what we can do with the extend side versus the retract side, okay? Let's apply 100 pounds of pressure to this side, okay? On the extend side, so A sub EXT will provide us with 1,256 pounds of force, of extending force, all right? Now, let's take that hose and hook it up over here, and let's same 100 PSI, but this time we only have, 9.42 square inches of surface area, and when we apply 100 pounds of pressure to that, we wind up with 942 pounds of force on the retract side, okay? So you can see a difference right now. We're going to be able to extend with more force than we're going to be able to retract with, okay? So that's the difference between the two, and that's how you calculate those, okay? So we've covered a lot of information right here, but this is how you determine whether or not the forces of extend versus retract, okay, on a single acting cylinder, all right. So obviously we learned here is based on the surface area. If we apply the same amount of pressure to the cylinder, we're going to get different forcing, our ability to move different forces is going to be different, okay. So that begs the question. Think about this. I'm going to leave you with a parting thought here. If I have 100 pounds of pressure on this side of the going into this side, the extend side of the cylinder, and I poured 100 pounds of pressure of fluid on the retract side, what's the cylinder going to do? Think about that for a second. And I'll get back with you in the next video on it, okay? Thanks for watching, and be sure to watch for the next installment. It's coming up real soon. Well, actually, as soon as you click on it. Thanks a lot.